Anybody there? Anybody there? Okay, I will start the lecture and then you can join whenever you're here. Okay. This will be the last subject we will talk about, which is the carbonate equilibria. This is very important. Okay, anybody here? Anybody here? Hello? Hello?
السلام عليكم.
عليكم السلام ورحمة الله. البقية الله يعافيك. البقية ما وصلوا؟
هلا ببعث لهم، لحظة شوي.
يلا، لأنه أنا كنت بدي أبدأ المحاضرة، قلت بس مدام صرتي واصل إن شاء الله كلهم they will join. أنا بعثت إيميل قبل شوي وقلت لهم in 10 minutes we will start the lecture.
شفناه كلنا. في صوت طالع من عندي دكتور.
نعم.
في صوت طالع من عندي.
لا، صوت يعني غير صوتك. هلا شفاء المفروض تكون وصلتنا.
فاتت شفاء.
شفاء موجودة؟
هين اجت دكتور.
أهلا وسهلا. لسه ضل.
احنا فكرنا على 45 عشان هيك.
نعم.
احنا فكرنا على 45، على 10 و45 راح تبلش.
أنا كنت بس بجهز، قلت لكم within 10 minutes تقريبا، يعني لأنه كنت I was getting things ready، بس قلت I will start on it حتى لو تأخرنا few minutes it's okay. مدام معنا I think we have 40 minutes. This lecture is not going to take that long.
إن شاء
أي
الله.
ثريا إجت؟
هاي الأخيرة دكتور حكيت ولا لسه ضايل واحد؟
لا، ضل عندنا كمان، بس this is هذا آخر subject.
في كمان محاضرتين حكيتها.
طيب، هاي المحاضرة وضل محاضرة.
أيوة.
في ناس على الويتنج روم؟ ما فيش. إبراهيم. People admit all.
السلام عليكم.
عليكم السلام. كلنا موجودين الآن؟ Everybody's here. Okay. Okay, so we'll start the lecture. If you have any questions, you can stop me and talk. Hello.
سامعني دكتور؟
سامعك.
بعد إذنك اليوم احنا راح ناخذ محاضرة ولا ايش بالضبط؟
محاضرة، هذه محاضرة. نعم. حكيت لكم بالايميل I will post a lecture، بس إذا بدكم تكونوا لايف معي you can. This is a lecture.
بس لأنه احنا حكينا لك المرة الماضية إنه نرجع نلتقي على أساس اليوم بخصوص نكمل الاستفسارات عن المشروع الأخير.
But you did not send me anything. I assumed you didn't want to. هيك الاسامبشن تبعي انا بشتغل. مش قلتوا you will tell me right؟
هو احنا حكينا لك الأحد، قلت الأحد مشغول مع العائلة، قلنا
بس ما اتفقنا انه خلص، يعني انه we fixed، بدنا نعمل يكون في fixed time. على كل حال if we needed after this we can have a short meeting بعد ما نخلص المحاضرة، بس بدناش نحطه مع المحاضرة لأنه المحاضرة I will put it as YouTube I can get out of the system after the lecture, and we will make right after it another meeting, okay?
Okay.
So let's start the lecture. We finish. It's not going to be long. You understand, all of you? I will get out of the lecture, finish the meeting, then I will get on another meeting again. That way they allow us like fresh, like a new meeting, and we can talk about the project, okay? Okay, so this is the last subject we'll talk about. It's the carbonate equilibria. All of you know that our soils in Jordan are calcareous soils. This is very important. Why do we have a certain pH in calcareous soil? Why it should be a certain pH? This coverage, it will be both chemical and mathematical. There will be lots of calculations, lots of equations and math, but simple, but lots of it. Well, I don't expect you all to memorize each of this, but it's good for you to know that مين ببلكش في شيء إنه somebody has doing something, some noise. Everybody's okay?
تمام دكتور.
كل يعمل ميوت.
Yeah. So we will talk about the carbonate system. Like I said, I don't expect you to memorize any of this, and most probably I will not even ask you about anything in the final about this, but it's extremely important for you as soil young scientists to know how do we deal with the carbonate system in calcareous soils. This will be, like I said, thermodynamic, chemical, mathematical treatment, but it's extremely important. You will see how nice and how important we derive what should be the final pH in such system in a nice mathematical and chemical fashion. So let's start about the carbonate equilibria. Remember, carbonate equilibria, here we talk about the carbonate equilibria in soil, in calcareous soil, basically. The calculations will involve calcite, of course. When we talk about calcium carbonate, we assume it's calcite. Calcite is the official and mineral or name of pure calcium carbonate. We call it calcite if you don't know. Various conditions can be studied. We will study two conditions. Case one, the reactions involving pure calcite in pure water with negligible gas phase present. So the negligible gas we talk about will be CO2. So there will be no CO2 in contact with the calcium carbonate in this system. This is a simple system to introduce us to how we deal with it. And then we go to the second case, the reaction of calcite in pure water, but with the system open to CO2, which is like what happened in the field. In the field, you have the soil in contact with the atmosphere. The soil atmosphere has CO2, and the atmosphere above the soil has CO2. So there is contact, continuous contact between the soil and the atmosphere above it. So we have always CO2 in the soil. In the first case, zero. So case one can be regarded as that used for determining solubility of calcite. If we're talking about calcium carbonate in water without the presence of any CO2, so basically we are studying the solubility of calcite or calcium carbonate in a pure system. This is of little use, of course, because it's not, we use it as a model to understand the more practical thing we deal with. So it's of little use because it's impossible. We don't have in nature and in the soil lack of CO2. It's impossible to separate the soil from CO2. So that's why we say it's of little use. It does not help us too much, but it introduces the subject. Okay, these are the first equilibria we deal with, the equations. If you look at them, I'm writing them directly, but you can write them in a simpler way to start with. This will be the dissolution of calcium carbonate. If you say CaCO3 dissolves to give you calcium, and carbonate. And this is how you write K for that. You know, the products, the activity of the products multiplying by each other divided by the activity of the reactant, which is calcium carbonate. So this is where K comes from. All of them will be the same way. So the one at the bottom in the denominator will be the one on the left, and these are the products. So calcium carbonate dissolves to give you calcium and carbonate. Then you write K. So we call this one K of calcium carbonate. And we will write the K's values in powers of 10. Instead of writing so-and-so times 10 to the minus so-and-so, this makes it easier for calculations. We can add, subtract easily with simple numbers as powers. The next one is that of the carbonic acid. You know that H2CO3 is carbonic acid. If it dissolves in water, it will give you hydrogen plus bicarbonate. So we call this one K of H2CO3, carbonic acid. The K of it is 10 to the minus 6.4. This one is that of the bicarbonate, the dissociation of bicarbonate. Bicarbonate dissociates to give you hydrogen and carbonate. So we call this one K of bicarbonate. The value of it is 10 to the minus 10.3. And this one, of course, you're familiar with that. That's KW, that of water. K of H2O is 10 to the minus 14. You should be familiar with that. And then we have another one. CO2 as gas dissolves in water to give you carbonic acid. So, of course, gases, I don't know if you learned this and you remember, we don't measure their concentrations in molarity or in any millimole or anything like that, like we deal with the ions. Gases, we measure their concentration by the partial pressure. So that's why we say P to indicate the partial pressure of CO2 gas. That is to give us the concentration of this gas. So when CO2 dissolves in water, the first thing it will give you is carbonic acid, and then you go to the upper carbonic acid, then can dissociate and so on. So far, so good? Everybody can hear me?
Yes, yes.
سامعين دكتوراه.
Okay,
سامعين.
okay. And if you needed something, or I think it's simple, but نركز, and it's not that difficult. There will be a couple of places that we have to really concentrate, but the rest of it is simple. So when calcite dissolves in water, carbonate ions react with water in a succession of reactions. Succession, that means one after the other. So the first thing we have, carbonate dissolves in water, and then the calcium carbonate gives us carbonate ions. The carbonate ion is what we're interested in. CO3, 2 minus, it carries 2 negative charges. Of course, in water, it immediately hydrolyzes. This is the hydrolysis reaction of the carbonate. So it forms bicarbonate and it releases OH minus. That's why the carbonate will always be an alkaline solution. And you expect that, and you know that. When you hear of carbonate, you know that. But this is why it is basic or alkaline, because it hydrolyzes immediately. It takes hydrogen from the water to form bicarbonate ion, and it releases the hydroxide ions, so it makes it alkaline. And then HCO3 plus H2O, it can form the carbonic acid, H2CO3. We say aqueous, although it's a gas. Carbonic acid is a gas, but we saw that we say we put the AQ to indicate it. This reaction really took place in water. So this is still gas, but it's in the aqueous system. So don't mix the two things. You should understand what we mean by this aqueous, although this is a gaseous form. This is a gaseous compound and it's not stable, but because it's in water, it formed in water from the bicarbonate, we say aqueous. It is in the water system. And then also it releases OH minus. So again, we see that the bicarbonate gave us another hydroxide, becomes more basic. H2CO3 is unstable. This is the one that formed, unstable. It always changes to CO2 gas, which leaves the soil system or any system you have in, or the vessel. If you're dealing with calcium carbonate in the laboratory, CO2 will leave as a gas and then will give us H2O as liquid. Equation 1C, there will be a lot of reference to these equations. So when you study, the best way if you want to learn it is to print them out, because we'll be going back and forth to some of these equations. We'll say 1A, we cannot write it again. 1B, we cannot write again. So you know which is the equation 1A we called 1A, which is the equation we called 1B, and so on. There will be many more equations later, and we will refer to them. So when you study and you want to learn it, just print them out and put these papers next to you so you can go back and forth to this. Yes?
دكتور اللي هي معادلة ال1C اللي هي H2CO3 بالأكوس فيس، كيف هي بالأكوس فيس وهي مش مع ال H2O؟
هلا كلنا بنعرف انه هلا مثلا لما انت تسبحي في المي موجود فيها اكسجين ولا ما فيها؟ فيها. مش ذائب بمعنى انه ذائب، هو موجود as molecules جوا المي. هذا نفس الشيء، الغاز تكون ولكنه موجود in the aqueous system، ما ترك. فمشان هيك بنحكي انه aqueous to indicate the position of it, where it is. It's in the aqueous phase, but it is a gas. You understand now? Just I gave you an example is how oxygen is in water. We all breathe it. It can be there, but it's there aqueous, but it's not dissolved. في فرق بين if it dissolves, then it becomes ionic. It changes to ionic. It becomes back again to HCO3. هذا لما بده يذوب, it will go back to HCO3 minus plus water. It breaks. Like we wrote here, it breaks down to CO2 plus H2O. So it's not a stable, but it is a gaseous phase. Okay? Understood now? Okay. Okay, so in this system, the species of interest are what we have seen so far: calcium ion, aqueous ion, carbonate, bicarbonate, H2O3, remember, aqueous gas, but it's in the aqueous phase, OH minus, H plus, calcium carbonate solid. That's what we started with, remember? We dissolved calcium carbonate from a solid compound, which is calcite, and water. These are the species that we're interested in this system we talked about. The activity of calcium carbonate solid is unity. We know that. You remember when I gave you that simple short thing about thermodynamics so that you're familiar with some of these terminologies. So all pure compounds, solid compounds, usually pure, remember, pure, not purity from outside. مش إنه مخلوط مع أشياء. No, pure in structure. The pure calcium carbonate, its activity is unity, is one. All pure liquids also, including water, the activity is one. For this, we can ignore them later. You will see, that's why we're saying when they're one, they're not adding anything to multiplication or division, so we ignore them. So this leaves 6 variables. We have 1, 2, 3, 4, 5, 6, 7, 8. Now we remove these 2, so this will leave us only the upper 6 variables to deal with. These are the species that we're interested in. Every species in solution containing a carbon atom must be matched by a calcium ion. This is one of the ideas usually students get a little stuck with it. It's simple, but we'll see when we write the equation. Every species in solution containing a carbon atom must be matched by a calcium ion. Okay, we write it. I'm going backward. Okay. So, the statement we just said, every carbonate species that's in the system must be matched by an ion of calcium. Can we understand why is that? Or it seems not logical to you? Does it seem logical or tough to understand? That's what we wrote. What do we mean by the brackets here? Brackets means we'll talk about molar concentration, millimole, mole per liter, mole whatever, but it's concentration.
يعني انهم من جايين من الكربونات، لانه الكالسيوم كربونات، مش هي كالسيوم كربونات اجوا منهم، انه لازم يتساوى الكربونات مع الكالسيوم عشان تفاعل منها.
بس انه يعني بس نفهم انه لاحظوا هون عندنا we have carbonate, we have bicarbonate and we have carbonic acid.
هاي انه هي تحللت، يعني تسلسل التحلل منها من الكربونات.
هلا مثلا لما نكتب CaCO3, remember we start with, that's what we are studying, the solubility of calcium carbonate, CaCO3. When it dissolves, one molecule of it dissolves, what does it give you? Calcium
calcium carbonate.
هلا for every مستحيلة, it's impossible for us to have carbonate without calcium coming with it, لأنه coming from the same molecule. So regardless what happened later, كمان, for every مشان هاي, this is what we mean. This is carbonate. It has to be matched with the calcium. It came from one molecule of calcium carbonate. Even this, it also originated from another molecule. You cannot have this and this coming from the same molecule with the calcium. So this calcium will give us another one to produce bicarbonate. And this one also has to come from another molecule. لأنه لاحظوا CaCO3, CaCO3, it has one carbon, correct? So you cannot have carbon here, from one molecule, impossible, So they have to be, that's why every time we have a species that has carbon atom, it has to be matched with calcium. لازم يكون معاها مربوط calcium لأنه إجوا from one molecule, which is calcium carbonate to start with. Impossible to have more than one carbon atoms coming from one molecule of calcium carbonate, which contains one C atom. Do you understand that? كلنا فهمنا؟ اللي ما فهمها, this is extremely important thinking حتى نفهم chemistry, simple chemistry, but you have to understand this concept. ما نتركها إلا وإحنا فاهمينها 100%. It got in our head. Simple بس لازم نفهمها. مشان هيك هلا برجع للي فوقها. آخر سطر. Every species in solution containing a carbon atom must be matched by a calcium ion. لأنه جاي من molecule نفسه, which is calcium carbonate. Okay? فمشان هيك بنكتب هلا لما نقول molecule, if I write molecule equals molecule equal molecule, the same I can also say mole of this, mole of this, mole of the, whatever the concentration is. So instead of counting atoms, we write the concentration, because concentration, remember, the mole, when I taught you in the undergraduate, remember what we said about the mole? It's the counting unit in chemistry. So when we're counting atoms or ions or molecules, we're saying also moles, correct? Because mole is Avogadro number of anything. So when we write the concentration of calcium, لأنه واحد ممكن يقول, how is that? This is crazy. Concentration of calcium equals the concentration of all of these. It has to be if they are all in this system, because this system comes only from calcium carbonate dissolution. So every molecule that dissolves will have only one carbon atom. For every time I see carbon atom, it must have come from a different molecule. Correct?
Perfect.
Do we understand it ولا بعدنا؟
فهمناها.
لا
مفهوم بحكي دكتور.
البقية everybody understands what I'm talking about?
Yes.
اللي
نعم
بعده
دكتور.
if you have some questions ask, don't be ashamed لأنه these are basic facts and I go through these. It teaches you how to think chemistry, how to think the right way, in simple way, the real chemistry. مش بس هيك والله اقرا ويلا وابصمها لي ومشي. No, we have to understand these simple things because they're very logical, but they need some thinking حتى نفهم من وين جاي هالشيء هذا. If one of you still don't understand قبل ما نمشي لأنه في كمان the next idea is just as good one also. After we understand these two concepts, things will be easy. So everybody understood this simple concept? I can move on?
Yes, you can. نعم دكتور.
الكل فاهم؟ يعني ما تخجلوش يعني حتى لو واحد قال فهمت والثاني ما فهم ما عندنا مشكلة.
لا أنا كويس دكتور.
يعني خلاص we all know exactly what it means. So this is why now simply we can write the concentration. We moved from every species that has that has a carbon atom must be matched with a calcium ion. That means also we can write the concentration if every species matched بنمشي من 1 ion to 1 mole to any concentration. Because what's concentration? Mole per liter, millimole per liter, whatever it is, it's all in molarity, in numbers, and so it comes from numbers anyway, from the Avogadro number, from the mole, from the same concept. But that's why we changed from species matching immediately to concentration. Now we say the concentration of calcium has to equal the concentration of all of these. Why? Because each one of these is matching one of these. فلازم يكون عندنا موجود enough calcium to match every species that's in solution that contains a carbon atom. Good?
Yes.
Okay. The solution, the next stage, the next step, command, this is very important. The solution must remain electrically neutral. Sum of positive charges must equal that of negative charges. We know that. You cannot have a solution which is negatively or positively charged. Impossible in nature. So they have to be equality between the positive and negative charges. Halla, concentrate and see why sometime we put 2, sometime we put no, 1 only. Why is that? To have that electrical neutrality. So we wrote 2 times concentration, remember, brackets mean concentration of calcium plus concentration of hydrogen equals 2 times the concentration of carbonate plus the concentration of bicarbonate plus the hydroxide. So we understand why did we put 2 in front of calcium?
To remain neutral.
Neutrality is for the solution, not for an ion. This is not neutral. This carries 2 charges. We talk about the solution must remain electron neutral, the whole solution. But each one of these is carrying a charge. These are ions. I cannot remove the charges from them. But why did we multiply the concentration of calcium by 2 and we added to that hydrogen? must equal concentration of carbonate times 2 plus the carbonate concentration, bicarbonate, plus the hydroxide. Do we know why? Do you understand? It's all from this simple statement. The solution must remain electrically neutral. Sum of positive charges must equal that of negative charges. Okay, I'll try to explain it simple and hopefully you will follow and you will understand. Hala, remember we said here, every species, we started from one ion. And from the one ion, we went to the concentration, which is, remember, mole per liter, millimole per liter, whatever unit we use. Because the mole or the millimole is a counting unit, right? When we say mole, that means Avogadro number of that ion. Okay, mole of charge is also the same. So now, each calcium ion carries 2 charges, correct? 2 positive charges. So 1 mole of calcium ion, how many moles of charges it gives me?
2.
2. كل واحد بيحمل شحنتين. فإذا it will give us 2 moles of charges. Each mole of calcium ions, because each one of them is carrying 2 charges. So if I take a mole of calcium ions, it will give me 2 moles of charges. So to know the number of charges that I have from the concentration of calcium, I have to multiply it by 2 to give me the charges, correct? Remember, brackets, concentration, moles. Multiply it by 2 to give us the charges, electrical neutrality. So this 2 times the concentration will give me the charges that are derived from calcium in solution. Good? And the hydrogen carries only 1 ion. So the concentration of it, mole, gives me a mole of charge. So I don't have to multiply it by 2. Carbonate carries 2 negative charges. So like we did with the calcium, we have to multiply by 2 because each carbonate ion gives us 2 negative charges. So to get all the charges from the concentration of carbonate that I have, I multiply that concentration by 2 to get the charges that come from the carbonate. Remember, we are adding here 4 charges. Then the solution must remain electrically neutral. Sum of positive charges must equal that of negative charges. So this equality for charges, not for the ions themselves. So the calcium, we multiply by 2 to give us the total charges that are provided by calcium. Hydrogen carries only 1, so I don't have to multiply by anything. 2 for the carbonate, because each carbonate gives us 2 negative charges. So we multiply its concentration by 2. Bicarbonate 1 and hydroxide 1. So we understand this equation now, simple. If somebody doesn't understand, say it. Ask what you don't understand قبل ما نمشي عنها. Everybody understand? I assume when I don't hear any conflict. All of you understand?
Yes, go on.
Okay. So now we saw that, remember, when you look at this, it's so different from this. But this, for different reason. This comes from the species. For every species of calcium, there has to be, for every species that carries a carbon atom, there has to be matched by a calcium. And this one, in neutrality, both of them have to be, they have to apply. These 2 conditions must apply. So of course, here we don't have the hydroxide, because here we're talking about charges. So equations 1 to 4, which we started from the beginning. Remember at first when we started, we named them 1 to 4. The equations of carbonate, bicarbonate, H2CO3, and so on. Remember? These are equations 1 to 4 from the beginning. And 1D, this is 1D, and 1E are sufficient to solve the problem. Remember we said we were left with 6 variables. After we had 8, we forget about the calcium carbonate because it's pure solid. So its activity is 1, and H2O is pure water, activity 1. So we neglect the 2. We were left with 6 variables. To solve 6 variables, you learned in بالماث بالرياضيات زمان كنتوا تتعلموا. If you have 2 unknowns, you need 2 equations. If you have 3 unknowns, you need 3 equations to solve it, and so on. So if we have 6 variables, we need 6 equations to find the values of these variables. So في عندنا 1 to 4 and 1D and 1E, that's 6 equations. With 6 variables, we can solve it. Okay?
اوكي
نكمل ولا ثقيل نوقف؟ لو هو يعني انا حاط لهون اليوم انه نكمل حوالي 9 سلايدز. اذا شفتوا انه غرقنا نكمل
عادي انا بالنسبه لي.
اوكي هلا because equation 1 to 4, if you remember, are written in terms of activities. If you remember, we had parentheses in them. K of calcium carbonate, K of bicarbonate, and so on. While equations 1D and 1E, we just saw brackets, are in terms of concentration. Then how do we match activities and concentrations? They don't match. You can't put them in the same equations. A solution is valid only if C sub I, that means of all the species that we have, approximately equals the activity of I. And how can that be? It means gamma, you remember gamma? That's why I give you a summary and certain things so that you would remember these things. Gamma, which we call the single ion activity, remember? We assume it's 1 because remember, concentration activity equals concentrations times gamma. Remember that? The activity of B, when we studied, or I or whatever, equals concentration of that species times gamma of that species, single ion activity. If the single ion activity is 1, that means concentration and activity are equal. So we are assuming, and when this assumption is very close to being correct, in very dilute systems. When you have very dilute system, remember ionic strength will be very low. Interaction is extremely low between ions. So this assumption is not far. So at the beginning, we can assume this assumption. It appears at first as if the problem cannot be solved. We cannot obtain gamma of I values until the ionic strength is determined. And the ionic strength cannot be determined until the problem is solved. Remember those tips that I gave you in one lecture not long ago? The steps, how we calculate first assumption, how we calculate the ionic strength, and then we calculate gammas and so on, and then activities. You remember those ولا نسينا؟
لما بنحسب ionic strength.
I gave you how we, the step 1 to step 6. You remember how we go through successive approximation? We start saying that the concentration is the same as the activity, and so we start with that type of thing to find start with the first approximation of ionic strength. So anyway, you go back and study that section, but that's what we're assuming at the beginning. So until the ionic strength is there, and the ionic strength cannot be determined until the problem is solved. So it looks like we're going into circle. How do we start? This difficulty can be overcome by a series of successive approximations. That's the one what I discussed for you a while back, if you have forgotten, but there is one lecture that I told you at the end. The same lecture I talked about ionic strength and Debye-Hackl equation. At the end, I introduced that part of it, although it's for the undergraduate, for you to reach this aspect, because I knew we will use it later. in which the problem is first solved assuming activity coefficients are unity, this like what we said, gamma sub I equals 1, and determining an ionic strength. If I have gamma 1, then we have concentration of all the ions we have. So you calculate an ionic strength, which is not accurate, but we say that's first approximation. Then the activity coefficients are determined. If we have ionic strength, you determine gammas, okay? And if you determine gammas, you determine the activity. And you keep on this until we get to what we want, okay? So to understand this, I'm not gonna go back again. You go back to your other lecture and read it again so that you know what we're talking about. Okay. Okay, so now we have, remember, 6 equations. Back substitution into 6 equations is not easy. We have how to solve. Remember, we have 6 variables. That's why I told you, this is not only chemistry, it's also some math. You have to use your head. Math, little math, and with some chemistry to understand, grasp what we're doing in this type of calculations. So back substitution in 6 equations is not easy when you have 6 equations from one variable to the next. In a first approximation, it's convenient to see if there are other simplifications. See if we can reduce our problems less. Make the 6 equations maybe smaller number if we can. طبعا sometimes through simplifications, but these simplifications have validity. مش كيفنا out of our head يعني يلا let's assume this. No, there has to be some logic behind what are some of the simplifications we can do. Equations 1a اللي هي اللي هنتكلم عنها and 1b show that the solution will be more alkaline than the original water. Remember, carbonate, قبل شوية I told you, carbonate hydrolyzes to give you bicarbonate, produces OH. What's OH? Alkalinity, right? Hydroxide, it raises the pH. The next action, HCO3, also with water, it gives HCO3, produces another OH. So we are producing OHs in these equations. So the pH, it's impossible to be like the original water, right?
Okay.
Impossible. So equations 1a and 1b show that the solution will be more alkaline than the original water, so that the final pH will be above 7, which is the pH of pure water. Remember, 10 to the minus 7 times 10 to the minus 7, that's where we get 10 to the minus 14, the kW of water. So assume, since we know it's above 7, assumption, we say, okay, let's assume it's 8. The pH is 8, not far from 1 unit. So we're assuming because of this, you see the logic behind this? It's not out of our head. It's from the logic of what we see what's happening from our knowledge of chemistry. Carbonate plus water gives us bicarbonate, produces hydroxide ions. This reaction also produces hydroxide ions. So we are producing hydroxide ions. That means the pH will go higher than the original water before the dissolution of calcium carbonate in that system. Okay, so we know now it's above 7. Assumption, say, okay, well, let's assume it's 8.
دكتور ممكن نفرضها مثلا شيء ثاني مثلا 8 ونص 8 9 ولا ما بصير بس 8 محدد يعني؟
لا مش محدد يعني the scientists that started this يعني at the end we will find the real one. هذا assumption is to make things easy. ليش أحط مثلا 8.5 وأعقد حالي بالأرقام to make it more complicated? So it's just for simplicity. But there is no sacred thing about this 8.
يعني عادي مثلا لو فرضت 9 أو رقم ثاني.
Yeah, you see what we say? Assume. Assume, assumption that's not validity, not 100%, but we know for sure it's above 7.
Okay.
We know for sure. How much above 7, we don't know. Good now, okay, let's assume it's 8. But this assumption, مش إنه if somebody else assumed 8.3, 8.5, بنقول له, oh, you're so wrong. No, it's another assumption, but
اوكي.
This is for simplicity. Simple numbers for simplicity. Okay?
اوكي.
Okay. So, remember these from earlier. Equation 2 from equation 2. Remember that we had it from the beginning. So, and this is how it was. H plus times bicarbonate over H2CO3. We called it K of H2CO3 10 to the minus 6.4. Nothing new. This is from your earlier. So now remember we assumed pH, correct? What did we say? pH 8. What will the hydrogen concentration be? If we assume pH is 8, what will be the concentration of hydrogen? Hmm?
8 إذا هذاك بده يكون 14 قسم.
Yeah, pH is 8. So what will be the hydrogen concentration? ولا ما بتعرف انه pH
هي شفت اللوج حتكون
6
بحكي شفت اللوج للاتش.
طيب
راح تكون 1.10 أس 9 ناقص 9.
لما تكون هلا لما نكون المي نيوترال اوكي what will be the concentration of hydrogen and hydroxyl قبل شوية حكيت لكم what will be the concentration of hydrogen and hydroxide in pure water
1.
كيف 1 يا حلاوة كيف 1 10 to the minus 7 right مشان هيك KW is 10 to the minus 7 but if I have pH remember minus log بدنا ناخذ minus log is the pH for the hydrogen itself بده يكون a negative power of 10 صح؟ حتى يطلع لنا pH 8 hydrogen has to be 10 to the minus 8 correct؟ ناخذ minus log
خربطنا والله تعيد شوي ما فهمتهاش انا هون ضعت.
طيب هلا hydrogen concentration at pH 8 لازم يكون 10 to the minus 8 هلا ناخذ minus log 10 to the minus 8 شو بيعطينا؟ 8 صح؟ مش اللوج minus 8 minus log بصير 8 فرجعنا pH equals minus log hydrogen هلا بدي العكس هنا so the hydrogen will be 10 to the minus 8 بالassumption the assumption that we took a minute ago we said assume the pH is 8 so hydrogen ion already I know from this assumptions correct it will be 10 to the minus 8
صح ايوه صح انا خربطت بالرقم
اوكي فهلا مشان تشوفوا لما تشوفوا رقم جديد تقولوا هذا منين اجى هلا so this is from the assumption so from this equation remember we took this هلا ضرب التبادلي HCO3 over H2CO3 بنحط الهيدروجين تحت هذا you understand
نقلنا
هذا مش على واحد هذا الكسر فبننزل الهيدروجين هون تحت فبصير 10 to the minus 6.4 over hydrogen equals this وهذا K نفس هاي الفاليو اوكي فبصير عندنا this ratio HCO3 minus over H2CO3 equals 10 to the minus 6.4 over 10 to the minus 8 which is hydrogen this is what we wrote here you follow
طب دكتور ال6 ماينس 6.4 كيف اجت؟
هذه اجت هذا كي هذا from thermodynamics هذا من الجداول يعني معروف في الكيمياء the first I gave you 4 equations at the second slide هذول known values هذا مش بكيفنا these are known and available مشان هيك حطينا الفاليو تبعه على طول
تمام
شلنا الكي of H2CO3 هاي القيمة تبعه this is its value هلا الهيدروجين نزلناه تحته 4K هذا K وهي K نفس الفاليو هاي بنشيل الكي وحطينا قيمته
تمام دكتور
this is the value of it وهذا بضل عندنا شو الريشيو HCO3 minus over H2CO3 this over this is the ratio equals this over نزلنا الهيدروجين هون صار 10 to the minus 8 تحتيه. We understand? Simple math.
Yes.
Okay. فهلا you understand انه كمان احنا الباور لما نرفع هذا فوق بصير هذا positive, right? 8 minus ولما نضربهم في بعضهم بنطرح
8 ناقص 6.4
وهذا اللي طلع 1.6. طبعا 10 to the 1.6 قريب الى 10 سكوير، يعني 10 سكوير قديش؟ يعني كم مرة؟ لو بدي احوله الرقم 10 to the 2 شو يعني؟
100
يعني 10 ب 10
100 طيب معناه 1.6 قريب لل100 مش 100 بس very large number, right? It's a large number.
نعم صح
يعني 100 قليلة. لما أقول this is 100 times the other thing هذا small number؟
لا
كبير.
لما أقارن شغلتين فلاحظوا هاي الرقم شو هو؟ The ratio of HCO3 minus to H2CO3 equals this. معناه this is that many times more than H2CO3.
يعني البايكربونات أكثر من
way larger قريب لل100 مرة يعني أقل طبعا بس كمان أعداد كبيرة. فمعناه H2CO3 is small relative to HCO3 minus and can be neglected in first approximation. بقدر أبعد عنه مش برميه طول الأمر بس remember we are trying to find simplification تساعدنا في حل المشكلة. So we simplify, but at the end we will calculate all of them. You understand?
Yes.
So now from this, you see what tricks we play? Mathematical and chemical tricks, both together. Mathematical and chemical tricks. We saw this. This is fact. هذا مش جديد. This is a fact chemistry. We know that the H times HCO3 over H2CO3 it has a K وهذا موجود in literature exact known value. We assumed for simplicity hydrogen equals 10 to the minus 8 pH 8. So now we have a value approximate, but we say okay at first approximation we have a value. From this approximation we discovered we can approximate another thing. We found that the bicarbonate compared to carbonic acid so much higher. So I can neglect this. Well, this is not very important. This is way higher, way more important than this one at this stage. For at this stage, first approximation, remember, not final solution. Okay?
تمام دكتور.
Okay. هلا راح نوقف هون، راح اوقف هذا بس
الريكورد.
اوكي وبدكم تعطوني حوالي 10 minutes or so لانه بيعمل conversion حتى مشان احط لكم اياها على اليوتيوب. It has to convert this. The conversion takes few minutes. Then I will join a meeting again and we can talk about the okay. So I will stop here. Wait for about 10-15 minutes. I can send you an email till you I'm ready. Okay. Keep watching your email.
تمام.
Okay.
تمام. اوكي يعطيك العافيه دكتور.
الله يعافيكم.